Hello everyone, welcome to my video. Now I'll walk you through my project on reference-based super resolution for face images. Let's start with a motivating example. Can you see the differences between the middle and the rightmost image? You may pause the video to guess which is the original image. Now, I will reveal the answer. The middle image is the original image. They look pretty similar, right? The rightmost image is the super resolved image, also known as SR image, obtained by passing the low resolution image through a state-of-art super resolution convolution neural network. But how is this useful in the real world? If I ask you to study the body parts of a butterfly, will you prefer the left image or the rightmost image? I believe we will prefer the rightmost image, which is the clearer one. This is the similar case to the task in the medical field, where researchers have to study medical images to diagnose the presence of diseases. So this is one of the real-world usage of super resolution. However, for my project, we are more concerned about reference-based super resolution, also known as RefSR. So, what is RefSR? RefSR is a subdomain of super resolution. It uses an additional information like a HR high-resolution image. The rationale is to enable the network to learn the usage of the relevant high-frequency details from another additional HR image, which is also known as reference image, for improving the super resolved image. I will now bring your attention to some of the state-of-art network that I will be discussing for this video sharing. The first network is Super Resolution Residual Network, SRNet. It is one of the first SR network that uses very deep convolution neural network, also known as CNN, with skip connections to perform this SR task. Notably, it has also obtained a remarkable performance in the SR field. Moving on to the next state-of-art network, Super Resolution Neural Textual Transfer, SRNT, is a RefSR network that introduced an interesting concept to create a better reference by swapping the most related details based on the texture difference between the blurred reference image and the upscale low resolution image. It uses a generative adversarial network, also known as GAN. So, what is GAN? GAN consists of the generator network and the discriminator network. The generator network simply creates the fake images, and the discriminator network differentiate them from the real one. In a SR task, the random noise input is replaced by the low resolution image. Enough of the general state-of-art discussion. Now we will talk about the possible technique to improve SR image. Number 1. Improve the input image by bicubic interpolation. The rationale for this is to ease the network in learning the upscaling effect. Number 2. Insert the reference image to a good SR network. The rationale is that the SR network is already performing well and is likely to perform better with more input data. Number 3. Align the reference image by rotation with respect to the orientation of the low resolution image. This is to reduce the effort for the network to learn the alignment. By improving the input image using bicubic interpolation, the SR performance indeed improves. We can see the effect throughout all the different scaling factors, so we can conclude that it will improve the SR performance based on our rationale. One point to note is that the SR network used here is SRNet. Secondly, we also insert an additional reference image into SRNet, but the performance did not improve. Therefore, we conclude that it's not learning well for this SR task. How about aligning it to the LR images? Note that our dataset contains face images, therefore, we can align reference image to its respective LR image with the facial landmark given in the dataset. However, this is similar to the previous case. Later on, we did more experiments and realized that the design of the network must be engineered for the reference image to be purposefully used. Before diving straight into SRNT for RefSR discussion, I will show you that a GAN network can create a more realistic image despite of the lower performance indicator peak signal noise ratio (PSNR). You can observe closely to the eyes and mouth area in the example on the left. SRNet is producing better photorealistic output but is having a lower PSNR compared to SRNet. What can we say about this? SRNet is actually optimized in the mean square error, which also optimizes PSNR. A GAN network like SRNet is trained to create image that fool the viewer in believing it to be a natural image, thereby producing a perceptually nicer output. Therefore, it's not fair to compare SRNet with SRNet. A GAN variant of SRNet, SRGAN, will be used in the subsequent experiment as the baseline. I have also tried the align reference image with SRNet, but it did not perform well. I also verified that it does use the reference image, however, the alignment is not effective. Knowing that, I included a flow refinement module into SRNet to do the alignment of the reference image based on the low resolution image using flow warping. Therefore, I named it FSRNet. We observe a better performance in FSRNet compared to SRGAN and SRNet. However, we should study the output of the flow refinement module. With a closer observation, the irrelevant details in the reference image is blurred instead of performing the alignment, which also aid the learning of the SR task for the network. Before we end, we'll look into one important component in RefSR, which is color. Let me introduce Adaptive Instance Normalization, ADA-IN. It basically transfers color from one image to another. We can transfer color from the low resolution image to the reference image for the network to easily identify what details are relevant for RefSR tasks. On the left is the original ADA-IN. However, we can see the large amount of color transfer from the background to the face. Therefore, we suggested localized ADA-IN to do it patchwise as shown on the right. This is similar to the patch matching done in SRNet to find the related texture. Lastly, we have discussed the results of some techniques that possibly could improve SR performance. We also saw an improvement in SRNet using additional architectural change. One possible future work is to incorporate the color component into RefSR network. For more discussion and findings, you may read my report at Dr. NTU. Now I will close off the discussion. Thank you for your kind attention.